All right, we have this lesson here on finding all zeros. The last lesson we showed you were finding all rational zeros, and now the equations we're going to work with, the functions we're going to work with, are a little bit different because some of the answers are not always rational. Okay, so if we look here, find all the zeros of the function f of x is equal to x cubed plus x squared plus 9x plus 9. And we still go about in finding our possible zeros, which possible zeros are positive negative 1, positive negative 3, positive negative 9. And remember, q's on top, and I said that wrong. 9 looks like a q. That's probably why I said that. P is on top, q is on bottom. Alrighty, let's just pick some numbers. Let's see which ones we can find to be rational. Let's figure out which ones are rational, and we set up synthetic division. 1 times 1 is going to be 1. Then we add, we get 2. 1 times 2 is 2. 1 times 11 is 11. And this is 20. So we know that 1 is not a solution here. 1 is not a 0. And so the function does not cross the graph. The function does not cross the graph at the x-intercept of 1. So how about negative 1? Negative 1 is an option. So 1 times 1 is negative 1. 1 times, let's try this. 1 times 0. 1 times 0 is 0. Add these, we get 9. 1 times 9 is negative 9. Add those, we get 0. And there we go. Negative 1 is a 0. Now, how many zeros are we looking for? You see this number here? The highest exponent is usually the number we're looking for. We're looking for 3 roots. Possibility that some of them can be irrational or rational, but also we could also have imaginary roots, which are roots that don't necessarily cross the x-axis. Don't forget it is possible to have repeated roots. Just a quick heads up, a repeated root is where, like say, if this was 2, I know that this is a function that has x squared in it, and so 2 would be the one root. And what's the other root? Because this number says you're supposed to have 2 roots, so the other root would be 2. So you just need to remember, sometimes you can have the same root twice in your answer to identify how many roots you should have. Okay, so we know negative 1 is a root, and let's go ahead and drop everything down. This was x squared, or I'm sorry, this is x cubed, so this one's going to be x squared, and this one here will be x. This is it. So if we have x plus 9, perfect square, but that is not the difference of 2 perfect squares. If it was the difference of 2 perfect squares, we'd be set to go. But that's not the difference of 2 perfect squares. So because we're trying to find all the zeros, we can think of this as being set equal to 0 and solving for x. X squared is equal to 0, or I'm sorry, should probably learn how to do basic algebra. How do we get x squared by itself? Well, we are supposed to subtract 9 from both sides. Subtract 9 here, subtract 9 here. X squared is equal to negative 9. And what do we have to do now to get rid of squaring a number? Take the square root, and the square root of x squared is x. You took the square root of both sides, you have to have positive and negative. And what's the square root of negative 9? Square root of 9 is 3. And then what's the square root of negative 1? I. How many roots are we supposed to have? We're supposed to have 3 of them, right? Well, negative 1 is 1, and then plus or minus 3i. 3i is the second, negative 3i is the third. And there's the 3 of them. Okay, let's look here at this one. Find all the zeros of f of x is equal to x to the 4th power minus 6x squared plus 5. Well, p over q, right? So p, factors of p are 1 and 5, and the factors of q are 1 and 1. So 1 over 1 is 1, 5 over 1 is 5, positive or negative for both of them. Alrighty. Basically, they all start out the same. You find possible zeros, use synthetic division here. 1, right here's a common mistake I see a lot of students make. That problem is already set up wrong. If you have x to the 4th, the next one is supposed to be x to the 3rd, then x squared, and then x. And then the, I guess x goes in there, and then the 5. So here is 1x to the 4th plus 0x to the 3rd power minus 6x squared plus 0x plus 5. So you have to put the zeros in front of the x cubed and the x to the 1st power. To do synthetic division, let's go. Drop down your 1. 1 times 1 is 1. Add them up. 1 times 1 is 1. Add them up. 1 times negative 5 is negative 5. Add them up. And 1 times negative 5 is negative 5. And we have a Yahtzee. Oh my, look at that. That is beautiful. Beautiful. X equals 1. Okay. I'm looking. We're supposed to have 4 roots. And if this was to the 4th root, this would be x cubed. It's not a real easy way to find x cubes, factor those, other than what we're doing. Possible zeros are 5 over 1. Same possible zeros as we have up here. Okay. Well, we know positive 1 is 1, so let's go ahead and use what we have here. Remember, we're not worried about this because factored out. Let's go ahead and use this to pick another one. Well, we've used positive 1. Let's try negative 1. Wonder what a double Yahtzee is worth. Could this be a double Yahtzee here? Synthetic division. So drop down your 1. Negative 1 times negative 1, positive 1 makes negative 1. Add them. Negative 1 times 0 is 0. Add them up. Negative 1 times negative 5 is a positive 5. And add them up. Look at that. That's a double Yahtzee right there. Negative 1 is the second. Okay, so remember that this was 1x to the 4th. I don't know why I put a slash through there. I wanted 1 x to the 4th here. This is 1 x to the 3rd power, and this is 1 x squared. 0x, and then 5 is the coefficient, and we don't need to worry about that. So now let's go ahead and factor this, since we have x squared minus 5. Well, remember, like I said, we're trying to find zeros, so we need to figure out where that's going to be equal to 0. Add 5 to both sides. x squared is equal to 5. How are we going to get x by itself? Square root of both sides. So the square root of x squared, they cancel each other out, leaving us with x. And we took the square root of both sides, so we have to go positive and negative. Square root of 5. Positive square root of 5. I guess it didn't really need a positive sign there. And negative square root of 5. Now right there is our 4 zeros. And remember, those are rational, 1 and negative 1, and then irrational, positive and negative 5, square root of 5. Back to the previous example, we had some, where we at? We had some imaginary solutions there for roots. Okay, use this one. You can test yourself to see if you have an understanding about what's going on. Go ahead and pause the video, you work this out, then hit play. I'm going to stroll through this answer fairly quickly and let you see if you know what you're doing. Okay, here I go. We know that the roots of p are not the roots. The factors of p are 1 and 4, and I guess there's also a 2 in this one. And right here, q is going to be 1, so 1 over 1, 4 over 1, and 2 over 1. And they're positive and negative for all of them. These are our possible roots. Let's see where we go from here. Synthetic division. Let's go with 1. 1 seems to be one of my favorite numbers to work with in this. 1 times 1 is 1. You're going to get a 0. 1 times 0 is 0. Add them up, you get a 4. 1 times 4 is 4. Add them up, you get a 0. Good job. That's what we want. So, like I said before, there's a Yahtzee, leaving us with, this is x cubed. So there should be 3. There should be 3 zeros there. If that was x cubed, then this is x squared. And this is x, and then that has the constant. So that's a positive 4. Trying to solve this out, so remember we're trying to find 0, so we can set it equal to 0. We know that x squared is equal to negative 4. And we took the square root of both sides, so x must be equal to positive or negative square root of negative 4, which x is equal to positive negative 2i. 2i is one solution, and negative 2i is the other one. I can tell you I'd rather have positive 2i than negative 2i. Number one, I think negative 2i would hurt. If I had, like, if I began with 2 i's and I lost 2 i's, that would probably not be very good. Plus, I probably wouldn't be able to see very well. It's just my own personal opinion there. I'd rather go with positive 2 i's. But in this function, both of them are the actual rational, or I'm sorry, the actual roots, the actual zeros. Remember, we have 1 rational, which is the number 1, and we have 2 imaginary, the positive 2i and the negative 2i. Alrighty, that's all I have for you at this moment. We will see you on the next ride.